Then we've got the resistance of the strain gauge. This one happens to be 120. And this is just sort of a graph that kind of shows advantages of 120 versus 350. And with the 350, I would lump the higher resistance gauges in here as well, maybe 1,000. Today, we can manufacture gauges up to 10,000 ohms of resistance and even higher. For most practical stress analysis applications, most of the time 350 and 1,000 is about as high as you go. But if we look at 120s, the advantages of them is typically they're a little bit smaller in size. They're a little bit lower cost, not a lot, but a little bit. And typically they have a slightly better fatigue life. The reason that the fatigue life is better is that they're made out of a thicker alloy. Strain gauge alloys typically run somewhere in the neighborhood of 100 to 200 microinches thick. So it's a very, very thin metal that we're using. And when the resistance is lower, we can use slightly thicker metal. So that makes the fatigue life a little bit better. If we look at 350 ohm gauges, what you'll find is that since the resistance is higher, there's less current. And the less current means that you can achieve a better signal-to-noise ratio. And a lot of times in stress analysis, customers use 350 and sometimes 1,000 ohm resistance gauges. But what it allows you to do, since there's less current, you can increase the voltage that you're using to supply to the Wheatstone bridge. And when that voltage goes up, your output also goes up, and it's directly proportional. So if you go from a 1 volt excitation to 10, your output goes up by that same ratio of 10. If you had a battery-operated piece of equipment that's using batteries for powering it, definitely you'd want to use a 350 ohm gauge or maybe higher. We've got an application where we're working with a company in the U.S. that builds construction equipment, and they mount a little pod on the bottom of the equipment that's got the strain gauge in it, and it's got batteries in it, and it's got electronics in it that transmit the signal out through telemetry. And this little module, the strain gauges that they're using, if you can imagine a piece of construction equipment, you don't really want to have to go out there very often to change these things out. So what they do is they use, instead of 350 ohm gauges, they use 3,000 ohm resistance gauges so that those batteries last a lot longer. And then if you've got lead wire resistance, like if you've got long runs of cable, sometimes in explosive testing, sometimes very large structures, you can have very long runs of cabling, and it's a good idea to go to at least a 350 ohm resistance strain gauge to minimize those effects.